Hi, welcome to the channel. I'm Mrs. R. Let's do some math. Today we're talking about literal equations. Now, the definition of literal equations is actually not very helpful. The definition just says it's an equation where the variables represent known values. Now, that actually happens quite a bit. For example, there's a famous equation that says E equals mc squared. Now, E is the energy, M is the mass. You would know at least one of those things for your item, whatever you were measuring. But C, there's a letter there, but it's not actually a variable. This is the speed of light. So with these literal equations that you see in your algebra class, you're going to see a lot of letters. Now, sometimes these letters represent things that have already been measured and they're just easier to write than the full number. Sometimes they represent things that could be unknown, but as long as you know the other ones, you can solve for it. Basically, the literal equations part of Algebra 1 is just practicing manipulating equations. Another example that you might be familiar with is volume of a rectangular prism. Volume equals length times width times height. Whole bunch of letters, but if you're being asked to find volume, you'd be told the length, substitute the number in, you'd be told the width, and you'd be told the height. So when it says known values, they are mostly known values, even though we have this formula that is a bunch of letters. So I have 3 examples we're going to do with this. And this is how the instructions for literal equations tend to look in your Algebra 1 class. You get some kind of formula, some kind of equation with a whole bunch of letters, and then you get told to solve for a certain variable that's in there. Now, you might have to do the same problem 3 times. Maybe you have this problem set where it says solve for x, then separately solve for m, separately solve for z, and you have to work with that same starting equation 3 times. Now, we're just going to do one for each of our examples, but you'll be able to see kind of the process. So when it says solve for x, that means our goal is to work with this equation, use distributive property, use factoring, use properties of equality, and eventually we're going to get to x equals, and then whatever is over here. But the goal, when it says solve for x, you are trying to get x all by itself. So let's see what steps we can take. Now, the first thing I notice, because it said solve for x, and I'm kind of looking at that x, I see the negative sign there. I know it doesn't say solve for negative x, so let's go ahead and take care of that first. I know if it says subtract x there right now, I could add x to both sides. Now, it doesn't matter what x is. If I had a negative version of it, and then I add the same number, it'll get me to 0. So those cancel to 0. And on the left, we have z plus x now. So our first step was just making sure the x was not negative because we need to solve for positive x. And now at this point, we just need to clear out any junk that is hanging out on the same side as x. So I look there and I see we've got this z that's adding with the x. So we'll use our inverse operations. We'll subtract z. And z minus z is always going to cancel to 0 no matter what z represents. And then we can't combine these because they are not like terms, but we can write it as m minus z. Where people get stuck and frustrated a lot with their literal equations is that this is the answer. We're not evaluating, we're not finding a number answer for x. It really is just rearrange the equation. So really the instructions could say rearrange. So the equation starts with x equals, and then whatever you have to fill in. Now, obviously, that letter would change based on what you're solving for, but that's the idea. You are just rearranging. Let's look at example number 2. These always freak people out with the fractions, but Our goal is the same. They gave us a variable to solve for. It says solve for A. So first thing I'm going to do is find where A is in my formula that they gave me, my literal equation, and see where it is, what's messing with it, what I might need to do. So I see it here, and it's not negative. In the last problem, the variable we needed was negative. We had to handle that first. But this one's in a denominator. And they didn't say solve for 1 over A. So we need this to not be in a denominator. So let's take a first step of inverse operations to multiply by A. On the left side, that really will just get us A times U. On the right, having a divide by A, but then multiply by the same A, those will cancel to 1. So we'll end up with K by itself. Now that we've handled kind of the troubling part, like the negative was a troubling part in the first example, the denominator was a troubling part in this one, we've handled all of that. Now we just need to get A by itself. And right now it says times U. So we'll do the inverse of multiplication. We'll divide. That will cancel the U's and leave us with A equals K over U. And we were solving for A, and we have A by itself now. So guess what? You're done. That's all it is. Now these first two examples were completely letters. There were no numbers at all, but sometimes you will have numbers mixed in. So we're going to try this one. We do still have 2 letters, so this is still a literal equation. You would know one of these letters and then use it to find the other one. And we're going to try to solve for x. So here's our x. There's nothing really troubling about the x itself. It's not in a denominator and it's not negative by itself. But there is a crap load of stuff on this side with it that we need to get rid of. So we'll have to think about what we can do first. There are 2 main things happening here. We have the plus 2c that we'll need to get rid of. We also have this negative 3 that's multiplying by x that we'll need to take care of. Keep in mind that anything we do, we have to do to the entire side. So if you wanted to divide by the negative 3 and handle that first, it's going to get ugly because you'd have to divide the entire thing by 3. And this part is not going to come out nicely. It'll make a nasty fraction for you. So we'll handle that negative 3 later. Let's work on that plus 2c. Now, obviously, if it's saying add 2c, the inverse of that would be to subtract 2c. So 2c, whatever c is, if you have 2 of them and then you subtract 2 of them, you've got nothing left. So those will cancel. We'll have negative 3x left on the left. On the right, when we go to look at this part, negative 3 and negative 2c are not like terms. So all we can really do is just write negative 3 minus 2c. So it might not seem like we're really getting very far, but remember our goal is to clear out around our x. And there's definitely less on this left side than there was before. So we are making progress. All right, let's go ahead and handle that negative 3. It says negative 3 times x, so let's divide by negative 3. Now remember, the entire side, all the way across on your fraction bar there. So the negative 3 is on the left, cancel to 1, and we are ready to have just x by itself. On the right-hand side, we have that negative 3, and then we have some negatives up at the top. While it's really close to being simplified, we don't want to leave negative in the denominator. So what I'm going to do is actually factor out a negative 1 from the numerator. So if we had negative 1 times 3 plus 2c, we could use the distributive property and get this, right? Do you see how negative 1 times each of these would change the sign there? So I've just kind of pulled out that negative 1. Then if we consider the negative 1 at the top, the negative 3 at the bottom, we've got a negative divided by a negative. And those parts, the negatives will cancel, and overall we'll have a positive fraction. So we'll have 3 plus 2c over 3. Now this actually is a perfectly fine answer. Some people would look at this and freak out thinking they need to simplify it, but this is fine. There's no more factors that cancel, so this is a good answer. Now, if you have a teacher who's really picky about how your answer comes out, there is a way to change the way this looks so it's not one giant fraction. So if you already have everything you feel like you need for literal equations, that's awesome. Go on, shut off the video, go do what you need to do. But if you're worried about trying to simplify this because you think your teacher might require it, stick with me for a minute. So if we just focus on that 3 plus 2c over 3. Anytime you have two terms in your numerator, you can split that fraction. So it's kind of like, what would we have done if we wanted to add fractions to get this answer? So it's like you put one numerator and then add the other numerator, right? That would have gotten us 3 plus 2c. But since we need common denominators to do that, and 3 is the denominator we ended up with, we'd have 3 as our common denominator. Now the 2c over 3, that's not going to change at all. That can't reduce. But 3 over 3 does. So this is where you might want to try to simplify this a little bit. So you can say 1 plus 2c over 3. And that would have been our x value. So this is like an alternative answer. Most teachers, I do believe, would accept this first one that we got. But if you're worried about it, or if they've specifically said to simplify everything and to get something that looks like this, then now you know how to do it. So that's been literal equations. We're really just manipulating, rearranging, just kind of playing with those algebra rules. If you found this video helpful, please like on the channel so that we can get these videos going out and be more visible to lots of people. If you still have a question or you have another concept that you'd like to see done, just leave a comment and we'll take care of that as soon as we can. But otherwise, that's it for today. I'm Mrs. R and this has been me doing math. Thanks a lot. Have a great day.